Hey guys, Mr. Mice is here with you. How you doing today? It's been a while since I've been on the video, so here we go. Look, I'm going to do a video on changing from the definite integral to a limit of a Riemann sum. This is on the AP Calculus AB exam. Actually, it's on AB or BC exam, and it's one of those just a little bit of a different topic here. Really easy if you just know where things are located. So all I'm going to do is explain how to write them. I'm not going to explain what it means by it, really the background concept. Is just kind of how to locate it and how to answer the problem and convert from a definite integral into a limit of Riemann sum, or from the Riemann sum to the definite integral. Let's take a look at some examples. It should be a quick one, guys. Here we go. So here's the concept. The integral from a to b of f of x dx is equal to a Riemann sum. Remember, an integral is defined as the area under a curve, right? We learn to take Riemann sums to estimate the area under a curve. But if I take these rectangles like this, all right, I don't know why I drew a normal model here. If I took the rectangles here, okay, I'm just drawing real rectangles, and this right here, this is delta x, right? This is the width of the rectangle. If I start to take that delta x and I start to shrink it down about more and more rectangles and more rectangles, then I'm taking a limit, right? I'm taking the limit as my rectangles start to get smaller and smaller and smaller. So that's what an integral is. It's really just the limit of a Riemann sum. So the limit as n approaches infinity of the sum of the rectangles. Now the height of the rectangle is going to be your height is going to be your function. So your function right here is your height of the rectangle. And this delta x is your width for n subdivisions, okay? So this is what you got to remember here, guys. This is what you got to remember. And you got to remember this thing right here and where everything is located. Remember that this first number here is going to be your starting limit. The number that's above the n is going to be the difference between your starting limit and your upper limit, so your limits of integration. And then your function is what you're taking this stuff as. All right, so let me show you how this looks. The integral of 1 to 4 x to the 5th dx. So the way we're going to write this is the limit as n approaches infinity, the sigma k equals 1 to n. Okay, that stays the same. Parentheses. Now we're going to always start here, 1. So 1 plus, we're going to put a k here, times, we're going to subtract 4 and 1 and get 3. Divide that by n. And then that's whatever the x is. We're going to raise that to the 5th power. And then we got to multiply that by the difference, 3 divided by n subdivisions. And then that is your Riemann sum. Let's take a look at a couple of examples, and then one that was on a released example from the College Board for the AP exam. Okay, where I'm not going to, this is my whole worksheet, so if you're not in my class, you can go and take a look at this worksheet and do the problems on this worksheet, pause it, and you can take a look at the problems. Here are the answers real quick. Boom. Right? There are the answers. You can take a snapshot. If you're in my class, you got the answers anyway. All right, so let's take a look. I'm going to do number 1 here. So we're going to convert this limit into the integral. So when you're looking at this limit, and it looks like this crazy thing here, it's really an easy integral to take. Okay, this is going to be a Riemann sum into an integral. You're going to look at this first number. Okay, that's a. So you're going to put that there. Then you're going to look at the second number that's divided by n. You don't need the k. Disregard the k. All right, then you're going to subtract 2. Actually, you're going to add 2 and 3 together. Okay, and you're going to get 5. So that's going to be the top one. So you're going to add this number and this number to get your upper limit, which is 5. And then you're going to look to see if this is raised to any power or it has any type of other function. This is just f, so I'm just going to write this as f of x dx. All right, and that's it. All right, so if we're going the other way and we're going to write this as a limit, or as the limit of a Riemann sum, we're going to write the limit as n approaches infinity of the sigma k equals 1 to infinity of f of, all right, f of, where do I start? I start at 1 plus k times, I'm going to subtract 5 and 1 because I want this number here, so that's going to be 4 over n times 4 over n. Okay, and that's it. Okay, I'm going to do two more examples here. So now we're going to go from one that actually has a function in it. What's that function? It's cosine. Integral, where do we start? Start at 0. Okay, now this k is on the top. Okay, k pi over n, that's the same thing as k times pi over n. So what am I going to do? I'm going to take 0 plus pi. I just disregard the k. 0 plus pi is going to be pi. What's my function? It's cosine of x dx. And that's it. That's all there is to that. So let's take a look at the example that was from the released problems from the College Board. Which of the following integral expressions is equal to the limit as n approaches infinity of this thing? All right, so we locate this stuff. We got 1 plus 3k over n times 1 over n. All right, so I got to look at these, and you know what? They try to get a little tricky on these problems, okay? So here's where they start to get tricky. I would say with this one, notice here that the 3 over n with this k is different than that 1 over n, right? Before, in the examples that I gave you, these were the same, right? So we got to be a little careful. We're really going to look at the one that's outside here. All right, so we're going to look at the outside. So the b minus a is really 1. So that's going to help us, actually, because it's going to narrow it down. It's going to narrow down this answer to one possible answer, which is the only one in which our b minus a is equal to 1. Well, this is 3, this is 3, this is 3, this is 1. So the only answer here is a. So that's really one way we can do it. Let's take a look at maybe another way to do that. Now, the other way we can see is that we've got a 1 here, so we need this to also be a 1. So this is really 1 plus 3 times k, well, let's go k times 3 times 1 over n. And we've got a 1 over n. So our function here, our function is going to be square root. And now I said a, but remember that a would have been, that a in these problems here, look, see this a? Okay, this a is 1 here. But in this case, it's not going to be a 1 because we've got a 1 in our function. So our function, this is actually going to be 0 plus 1 plus k times 3, 1 over n times 1 over n. So that our function is 1 plus 3x. 1 plus 3x. Square root of that. All right, so that one's a little tricky one because you got to like format that differently. But again, I think the easiest way to do it is just to look at this 1 over n and see that that's going to be the width, b minus a. So which one of these is going to have b minus a like that? Okay, so the answer here is a. So there we go. That is definite integral, limit of a Riemann sum. I encourage you to try these other problems out here just to get practice on that. Again, if you practice it enough, this is really, really easy to get the answer right on the AP exam. Good luck, guys. You got this. We'll see you later.